Good day, students. Welcome to part 4 of our implicit differentiation practice series. In this clip, we're going to be going over an example where we have to find a region where the slope of a curve is defined, okay? We're going to be dealing with an implicitly defined function, hence the use of implicit differentiation in this problem. All right, so let's go ahead and take a look at an example. So, let's write down the instructions. So, example 1. Task is to find where the slope of the curve is defined. And the curve under consideration is a curve implicitly defined as 3x to the third plus 2y cubed equals 4xy. Okay? Alright, so before we start, let's talk a little bit about what makes the slope of a curve undefined. What makes a number undefined? Anytime you divide by 0, you end up with you have an undefined result, right? You have an undefined result. So if we can find the derivative of this curve, a function that defines the slope at any point, that helps us find the slope at any point xy. Let's call that function m of xy. Okay. If we can write this as a rational function, which would be the case here, p of x over q of x, I'm sorry, p of xy, because this is a implicitly defined function, it's not just one. So we have a function p of xy over g of xy. Anything that makes this denominator function g of xy equal 0 will cause this curve to have an undefined slope. Okay, so the original function will be defined anywhere except g of xy equals 0. Alright, so the whole procedure here is, first of all, we need to find the slope at any point xy by implicitly defining this, and that will give us m of xy, which will be a rational function. And what we'll do next is we'll set the denominator to 0, and it tells you where the slope is undefined. Hence, uh, the curve is going to be defined for everywhere except whatever makes this equation true. Okay, so that's basically the strategy we're going to use here. All right, so let's go ahead and find the slope of this curve at any point xy by using implicit differentiation first. All right, so let me rewrite this problem. We have 3x to the third plus 2y to the third equals 4xy. All right, so we're going to be looking for dy dx here. So we're going to have, I'm going to do term by term differentiation on the left side. So d dx of 3x to the third plus d dx of 2y to the third. Let me write that. Of 2y to the third. And then on the left side here, we have a product of two functions. So we're going to be using a product rule to differentiate this piece right here. Okay? All right, so let's go ahead and differentiate. I'm going to factor out this 3, so I'm going to have 3 times. Now the derivative of x to the third, we use the power rule. So it's going to be 3x squared times dx plus, and in this one we'll factor out a 2. If we differentiate y to the third, we're going to have 3y squared times dy dx. Okay, we're using the chain rule here, differentiate all the way. Okay, in this case, in this part here, let's make this 4 times, let's write it as 4 times, keep writing 4 times, I just want to write 4 times the derivative of xy. Okay, so we have 4 d dx of xy. All right, so we have a product of two functions here. We're going to use the product rule. This will be u, and this will be v. Remember that u v prime, the product rule tells us that the product of the derivative of a product of two functions is u v prime plus vu prime, right? So that's what we're going to be doing on the right side here. Okay, so let's go ahead and simplify the left side. 3 times 3 is 9x squared. The x just divides out to 1. And then here we have 6y squared dy dx. That equals um, 4 times. Now we're going to have u v prime is going to be x times dy dx plus vu prime is going to be y times dx dx. Okay? All right, let's leave the left side alone. It's just 9x squared. We'll bring it down plus 6y squared dy dx equals, I can now distribute this 4 to this first term. I have 4x dy dx. Dx dx just divides out to 1, right? So it's going to be plus 4y. All right, now we need to find the slope, which is dy dx. So the goal is to isolate dy dx. I'm going to correct all the terms with dy dx on one side and everything else on the other side, okay? So I'm going to move this 4x dy dx to the left side, and I'll move 9x squared to the right. All right? All right, so let's use the properties of equality to do that. So I'm going to subtract 9x squared from both sides. Subtract 9x squared. And then I'm going to subtract 4x dy dx. Okay? You can do this procedure mentally. I'm just trying to show it visually here. So that's going to give us, on the left side, we're going to have 6y squared dy dx minus 4x dy dx equals 4y minus 9x squared. Okay? So the question is, why did I choose to have dy dx on one side? The reason is because it enables me to factor out the dy dx and isolate it, okay? So I can factor out dy dx from these two terms. So I'll basically have 6y squared, or we can put dy dx on the front. Dy dx times 6y squared minus 4x equals 4y minus 9x squared. All right, so to finally isolate dy dx and find the slope, I'll divide both sides by 6y squared minus 4x and divide the side by 6y squared minus 4x. Okay, so divide dy dx is going to be equal 4y minus 9x squared over 6y squared minus 4x. So this function helps me calculate the slope of my curve at any point, okay? Remember we said that, let me put that on the side. We said that if we can find m of xy expressed as a rational function, p of x over, I'm sorry, p of xy, p of xy over q of xy, p of xy over q of xy, then what we have to do is basically set the denominator to 0. And when we set the denominator to 0, anything uh, that makes that equation true will cause the function to have an undefined slope. So we need the function to be defined. The function will have a defined slope anywhere except where the denominator function is equal to 0. Okay, so we have the slope here. So what makes this undefined? This is q of x, which causes the function to have a 0 slope. So we need to solve this equation. Basically, 6y squared minus 4x equals 0. Okay, so let's just isolate y to, let's just get y squared by itself. So what I'm going to do, we could add 4x to both sides. So we have 6y squared equals positive 4x. Can divide both sides by 6. We have y squared equals 4 over 6x. Okay, so the question is, when does the original curve have a defined slope? So let's write down the answer. The curve 3x to the third plus 2y cubed equals 4xy has a defined slope everywhere except where y squared is equal to 4 over 6x. So any ordered period that satisfies this equation will result in an undefined slope, hence the curve will have an undefined slope at that point. Okay, so there you have it. Alright, so thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here. You can click like to like this video if you did. And please post a comment to tell me what you think about this video. More clips can be found on mathyourself.com. Thanks again and have a wonderful day.